For our final lesson in this half of Unit 2, we're going to skip up to Lesson 7 in our online textbook, focusing on linear and quadratic systems. Our goal is to be able to solve systems of equations or inequalities that involve quadratics. So we've done a little bit of this already back in the first unit, where we solved systems of equations and had to graph some parabolas and see where they intersected with our linear functions. Here we're going to have that, but with greater than or less than, etc. So real quick, just kind of thinking of systems of equations, we either have a situation where the graphs do not intersect and therefore there's no solution. Maybe they intersect only in one point and therefore there's one solution, or they intersect in 2 points and therefore there will be 2 solutions. And so we've kind of dealt with this a little bit already, again, back in Unit 1. But here, these are going to be our 3 cases that we're going to explore and try to focus on solving by graphing. So again, we did this already in the last unit. So we have y equals x squared plus 8x plus 6. And so graphing that parabola, we're going to find the axis of symmetry is x is equal to the opposite of b over 2a, which is going to be negative 8 over 2 times 1. And so that gives us negative 8 over 2, or negative 4. When I plug in to find the y value of the vertex, I'm going to find that y is equal to negative 4 squared plus 8 times negative 4 plus 6. This gives me 16 minus 32 plus 6. So this gives me negative 10. So we're going to have the point negative 4 comma negative 10 for our vertex. And then we will build from there. So once we've got the vertex, negative 4, negative 10, we know that our vertex, building out from there, we're going to go over 1 up 1, over 2 up 4, over 3 up 9, and then of course over 4 up 16. And so that works because we have the 0, 6 as our y-intercept, so I have a little bit of confidence that I graphed that well. Obviously, you're going to use your grapher calculator to help on that as much as necessary, but the goal is, let's see if we can do that efficiently without our grapher. My black marker's fading just a little bit. We'll also graph the line y equals negative 1/3 x plus 4. Negative 1/3, negative 1 over 3, negative 1 over 3, back 3 up 1, back 3 up 1, back 3 up 1. And so we can find, or we can see, where those graphs intersect, and we can notice that they're not intersecting at any particular x comma y. So again, the way that we approach that in the grapher calculator, first of all, being able to graph that on graph paper is expected on this side of whatever class we learn to do that in. But when we graph these, if I do a normal zoom, a standard zoom, whoops. If I do a standard zoom, I didn't do a standard zoom, but you can kind of see that it looks very similar to the picture that we've drawn here. We can calculate the points of intersection using the calc function. So second calculate, and we can find out where they intersect. So again, we want to be able to use the grapher calculator to find the intersection. We're going to say the first curve I'm going to say is y1, the second curve is y2. Sorry, it's getting out of focus. But we're going to guess, and I want to guess for this point right out here, which looks like it's at about negative 8. So we're going to guess what happens at negative 8, and it tells us that it's real close to negative 8. It's negative 8.085992. So we're going to say negative 8.09. And then the y value there was 6.70. And so that's going to be about this point right here. Now there's another intersection that's right in there, and we don't know exactly what that is, but we are going to let the computer calculate that for us too. So we're going to calculate the intersection, again, between y1, enter, y2, enter, and then we're going to guesstimate that's about 0, right? It's maybe between 0 and negative 1, or negative 1 and 0. And so we know it's at negative, looks like 0.25-ish, comma 4.10-ish. rounding to the nearest hundredth. So these are the solutions. Our parabola intersects that line in 2 locations, and we can use the grapher to expedite that. And we'll be required to use the grapher to find the actual x comma y's. All right. So reviewing that from our previous unit that we did a little bit ago is, I think, helpful to kind of see how we calculate that intersection. With respect, and we're going to practice that a little bit in class as well. With respect to the inequalities, here's just a quick reminder of those rules. We always want to get y by itself and have y on the left side. So we have y is less than, y is greater than, y is less than or equal to, y is greater than or equal to. If it's arranged like this, then we know that for these we're going to have a dashed boundary that we shade below or above. We have the y's that are less than the curve. That means we're going to shade below the curve. Y is greater than, we're going to shade above the curve. Less than or equal to, greater than or equal to. These would be a solid line, a boundary that we would draw. And we would shade below for y is less than or equal to, above for y is greater than or equal to. So we want to make sure we do a great job with that. But just a reminder, when in doubt, use a test point. Plug in the x comma y and see if it makes the inequality true. So if we're going to solve these by graphing, we want to be able to graph these this parabola and this line. For this line right here, let me get y by itself first. I'm going to divide by -1, so that's going to change this as such. Graphing that line is going to be hopefully pretty easy. Up 3 over 1, up 3 over 1, down 3 back 1, down 3 back 1. And so I can make each of those dots on the graph. I can connect those with my ruler. Again, bring your ruler to class or your ID. A lot of folks like to use their ID. This is going to be a solid boundary. And we're going to end up shading below. So this is solid, and we're going to shade below. I'm not going to shade it yet because I'm going to do the parabola also. Again, x is the opposite of b over 2a. -6 over 2 is going to give me -3. Y is going to equal -3 squared plus 6 times -3 plus 1. So y is going to equal 9 minus 18 plus 1, or -9 plus 1 is -8. So we have -3, -8 for our vertex, and our a value is 1, so we know that we're just going to have the standard draw there. Here is the vertex, over 1 up 1, over 2 up 4, over 3 up 9. I want to make sure I count those right. And then over 4 up 16. So there's 8 and then 8 more. And this is going to be dashed. Not a solid boundary, a dashed boundary, and we're going to shade above. So let's do our best work here. Drawing that dashed parabola. So again, we're going to shade above the parabola, but we're going to shade below the line. So the place where they overlap is this section right there. All right? So we are below the line, but above the parabola, they don't intersect. We're below, we're above the parabola and below the line, so they won't intersect there. So this sliver of space is all that we are going to care about. All right, let's do number 2, or letter B, example 1B. Same idea. We've got 2 parabolas here, though, so you've got to do a good job graphing 2 parabolas. Luckily, we've got one that's in vertex form, so I know that we're going to have -3, 5, but our a value is -1/2. This will be solid and above. This one will be dashed and below. So let's go ahead and do this at -3, 5. We are going to go over 1 down 1/2, over 2 down 2, over 3 down 4 1/2. Let's see, 1, 2, 3, 4 1/2. Over 4 down 8, because 1/2 of 16 would be 8. Over 1, 2, 3, 4, 5 down 12 1/2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and a half. All right, so this is our parabola that is going to be a solid boundary, and we're going to shade above this parabola. I'm not shading it yet because I don't want to use all my marker. I only want to shade the spots where they overlap. The other one, again, we need to find the axis of symmetry. The opposite of 6 over 2 is -3. Y is equal to -3 squared plus 6 times -3 plus 3. So y is equal to 9 minus 18 plus 3. Y is equal to -9 plus 3, which is -6. So we have -3 comma -6. And over there we got an over 1 up 1. So -3, -6, 1, 2, 3, 4, 5, 6. Over 1 up 1, over 2 up 4, over 3 up 9. That was what, 6, 7, 8, 9. And then over 4 up 16. 1, 2, 3, 4, 5, 16 would be all the way over there. And this one is a dashed boundary, and we're going to shade below it. Oh, dang it. Boop and boop. Counted wrong. Oh, is that right? Oh, no, this is right. I just missed it. It doesn't go through that type. It goes through this type. All right, there we go. Sorry about that. All right, now, again, we're shading below the dashed boundary. So below, 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 all of that. But then we're shading above the solid boundary. And so where do those overlap? Well, folks, they overlap out here. And they overlap out here. All right? Again, above this curve and below that curve, there's no overlap here. So we're not going to shade in here and we're not going to shade in there. If we're doing color coding, that's totally fine with me. Your whole thing is going to be shaded in, right? And so you're going to want to make sure that you can see where they overlap. All right, for the last one, I want for you to do this on your own. So example 1C, I'll be looking on the Google Classroom that you did this along with the other ones. So see if you can graph these parabolas, or this parabola and that line, and then shade appropriately. Draw your boundary appropriately. Do this one on your own, you do this one. And then we're going to talk about this idea of a test point. So finish 1C, you do that one on your own. Example 1C is you. But example 2, I'll do A and B, and then I'll have you do C. All right? So I know this is getting a little lengthy here. But test point. A test point is where you find 0, 1, 2, 3, 4, and you say, is it in the double shaded region? And here we would say yes. So the point 0, -4 is in the shaded region, so that works. If you don't have a graph, then you can plug in the x value and the y value into your equation. Is -5 less than -4 minus 0? Is -5 less than -4? Yes, it is. So that works. Check. Over here is, not 5, is y greater than -3 times 0 squared plus 6 times 0 plus 1. Does it work? Is -4 greater than, that's 0, that's 1? No. All right? So this is a solution. 0, -4 is a solution. Over here, 0, -4 is not a solution. So picking a test point is one way in which you can determine where do I shade it. Or if we're asking the question, is this a solution to the system? Does it meet the requirements of the system? Is the y value actually greater than -3 times the x value squared plus 6 times the x value plus 1? Here we said it was no. Here we're going to test this one in a couple different ways. -1, -2. Let's see how this one goes. At the point -1, -2, this is outside of the shaded region. So it works for the line, right? It's above the line, but it is not below the parabola. So not a solution. It does not work. -1, -2 is not a solution. Does it work with this second system? Is -5 less than -2 minus -1? Is -5 less than -1? Yes, it is. So that works for the first one. Does it work for the second one? Here we saw the point worked for the line, but it didn't work for the parabola. Here it works for the line. Does it work for the parabola? Is -2 greater than -3 times -1 squared plus 6 times -1 plus 1? Is -2 greater than -3 times 1? -6 plus 1. Is -2 greater than -8? Yes, it is. So this is a solution for system 2. Is a solution for that system. It's not for this one, but it is a solution there. And so that's just testing the point. Does it work on the picture, or does it work algebraically? I want for you to try this one. Does 1, -1 work for system 1? Does 1, -1 work for system 2? You get to do these. This is 2 things that you get to do. You do example 2C. All right, yay. That's a smile in some cultures. All right, so give that a shot, and then we will discuss those. The you tries, you try them, you get the points. If you don't try them, you don't get the points, but give those a shot and let's see how that rolls. All right, that is the end of our lesson. Make sure you message me if you have any questions or be ready to ask them in class.